All right, 1.3, solving equations with variables on both sides. All right, so for the first example here, our goal is always to isolate the variable on one side of the equation. Doesn't matter which side, just on one side of the equation. So here I already have x by itself on one side of the equation. Here I have this x here with a constant on the other side. So let's move this piece over to the right side. So I have to do the opposite operation. I have to add 4x. So I get 10 equals negative 9 plus 4 is negative 5x. Once again, just use the number line if you have any issues with this. Start at negative 9, add 4. So you're going to the right. Right, so that's negative 8, negative 7, negative 6, and then negative 5. Okay, and then we want to get x by itself still. So now I need to divide. Here I'm multiplying, so I need to do the opposite of that. Divide, and I get x is equal to negative 2, or negative 2 equals x, same thing. But normally we have the variable on the left side. All right, it also says to check your solution, so we'll plug it in. And we get 10 plus 8 equals 18. We get 18 equals 18. Yeah, so the solution is correct. It works. All right, going on to the next example. Solve an equation with grouping symbols. Okay, let's see here. Okay, now there are a number of different ways to do this problem. I'll show you two methods. All right, just because when students see the fraction there, then they freak out right away. All right, I'll give you guys two methods to solve this problem. All right, method 1 is just distribute on both sides. All right, this is the distribution property. So I have 9x. Don't forget to distribute to the second term. A lot of students forget that important piece. Now I have 1/4 of 32. In other words, what's 32 divided by 4? Well, that's 8. And I have 1/4 of 56. What's 56 divided by 4? That's going to be 14. All right, so now it's a really simple equation to solve. I prefer always isolating the variable on the left side of the equation. So here I'll subtract 8x. And I get x minus 12 is equal to 14. Add 12. And I get x is equal to 36. Okay. Now what's the other method for solving this problem? All right, let me rewrite the problem first before I take a different approach. Okay. So this is what I'm going to do. I'm going to get rid of this fraction here. So I could multiply by 4 on both sides of the equation. Watch what this does. All right, multiplying by 4, both sides of the equation. So I get 12, 3x minus 4. And I got 1/4 times 4, which is just 1. 32x plus 56. All right, so now I just distribute, and I get 36x minus 48 is equal to 32x plus 56. Now in this case, we ended up with bigger numbers, which makes the problem a little more difficult to work with, not that much more. But sometimes this method can make the problem easier to solve, depending on what the fractions are. So same deal though. I'm going to subtract 32x. And I get 4x. And here I'll add 48. So I get 4x is equal to, what is this? 104. And I divide by 4. And I get x is equal to 26. Okay, so, oops, looking over at the left side, this should have been 26, not 36. There you go. All right, so I caught my own mistake. Mr. H gets extra credit. All right, going on to the next example. All right, solve each equation. All right, so first thing I'm going to do, you could take different approaches here. I'm going to show you two different approaches. You could distribute to start with, or you could divide by 3 on both sides to start with. It's your choice, however you want to do it, okay? Just showing you different methods for solving the problem. I'll just distribute here. So I got 15x plus 6 equals 15x. Here I'm going to subtract 15x. Oh, this is a funky situation. 6 equals 0. This cancels out. What? All right, well, what does this mean when the variable cancels out? When the variable cancels out, you look at the equality that you're left with. All right, is this equality true or is it false? Well, does 6 equal 0? No. All right, that's not true. They're not equal. So in this case, your answer is no solution. And here's also the symbol for no solution. It's a circle with a slash through it. All right, let's go to the other problem. We'll do the same thing here. We'll distribute. Got negative 8y minus 2 equals negative 8y minus 2. All right, so here I will add 8y. Cancels. That cancels 2. All right, another funky situation. What happens here? All right, the variable canceled out. There's no longer a variable there. And I'm left with this equality. Is that equality true? Is negative 2 equal to negative 2? Yeah, it is. So if that's the case, then we have infinitely many solutions. Okay. Now, you know what the answer is based on the situation they're in, but why is that the answer? You should be asking that question. All right, why is this no solution? Well, there's no solution because it doesn't matter what number I plug in for x here. Okay, I could choose any number. Any number that I plug in there, this equation's never going to work out to be true. All right, so that's why there's no solution. Whereas with the second equation here, I could choose any value for y. Plug it in, simplify everything, and the equation will work out to be true. The equality will work out to be true. And that's why there's infinitely many solutions, because you could choose any number you want, and it will work out to be true. All right, and that's it for today's lesson. So just go to the bottom of the webpage and begin the assignment. Make sure to ask for help if you need it.